In this video, we're going to go through how to convert from mass of one substance into mass of another substance when given a balanced chemical equation. So this is our mass-to-mass conversion. Things you should already know, and if you don't already know these things, you need to go back and complete these assignments or review this material. So number one, how to determine the molar mass of a substance. So remember, molar mass is written in grams per mole. And this is the conversion factor between grams and moles. So if I have 4 moles of a substance, let's say oxygen, the molar mass allows me to convert it into grams of oxygen. Because I know that from looking at my periodic table that 1 mole of oxygen is equal to 32.00 grams of oxygen. So if I have 4 moles, then I'm going to have 4 times 32.00 grams of oxygen. So molar mass allows us to convert between grams and moles of the same substance. It's got to both be oxygen because molar mass is for a specific substance. The second one says how to convert between grams and moles of a compound. And so the molar mass is how to find this 32 grams per mole, and then converting between grams and moles is what we just did here. So we're converting between moles and grams, or we could go the other way and convert from grams into moles. And then the last thing you need to know is how to convert between moles of a different substance. So moles of different substances when given a balanced chemical equation. So when given this balanced equation above, I know my mole ratio is 2 moles of H for every 1 mole of oxygen will produce 2 moles of water. So if I had, let's say I had 3 moles of oxygen, I am able to convert that into my moles of H2O by using this relationship 2 to 1. So if 1 mole of oxygen can produce 2 moles of water, 3 moles of oxygen can produce 6 moles of water. So if any of these things are still confusing, please refer back to the previous assignments and the previous videos and get clarification on that. Because we are using all 3 of these things when we convert from mass of one thing into mass of another substance. We're using all of the conversion factors that we've learned. So I know how to convert mass into moles of the same substance and moles into moles of a different substance. So I'm going to convert mass A, we're just calling this substance A. So let's say we have a chemical equation that says A goes to B, okay? You know, obviously A and B are not elements, but we're just doing a generic equation. So the mass of A, I can convert into moles of A. And I, again, will need to use my molar mass. So that's using the molar mass of A. And then my moles of A, I can convert into moles of B, and that is using the mole ratio from the balanced equation. And then my moles of B, I can convert into mass of B, and again, that uses molar mass, but this time it's the molar mass of B. So these molar masses are actually different numbers because we have different substances. So these are 3 different steps that I need to take in order to solve a mass-to-mass conversion problem. So I'm going to do an example problem. How many grams of water will form from 34.2 grams of oxygen, of O2? So I am given 34.2 grams of oxygen, and I want to figure out how many grams of water will form. So my steps are I need to go from grams of oxygen into moles of oxygen, and then moles of oxygen into moles of water, and then moles of water into grams of water. Each of these steps has a different conversion factor that we'll need to use. So to convert from grams of oxygen into moles of oxygen, I'm going to need to figure out my molar mass of oxygen. To convert from moles of oxygen into moles of water, I'm going to need my mole ratio. And to convert from moles of water into grams of water, I'm going to need my molar mass of water. So I need to know these three conversion factors. Well, my molar mass of oxygen from my periodic table, oxygen has a mass of 16 grams, but O2 would be 2 times 16, so it's going to be 32.00 grams of oxygen per 1 mole of oxygen. So another way of writing this is 32.00 grams of oxygen equals 1 mole of oxygen. Then my mole ratio I get from my balanced chemical equation. So I'm looking at O2 and H2O. So that's going to be 1 mole of oxygen can convert into 2 moles of H2O. So I have a 1-to-2 ratio. And lastly, I need my molar mass of water. So that's 2 H's. So that's 1.01 times 2 plus my oxygen, which is 16.00. So that's going to give me 18.02 grams per mole. And again, another way of writing this is 18.02 grams of water equals 1 mole of water. So I have all the information I need, and now I can just set it up. I'm going to start with my given. So that's 34.2 grams of oxygen. The first step I need to do is go from grams of oxygen to moles of oxygen. So that's my purple conversion factor. Since I'm converting from grams, I'm going to put my grams on the bottom. And I'm going 2 moles, so moles goes on top. And then I have, so at this point, my grams of oxygen cancel out. It should be grams of O2, so that cancels out, and I'm left with moles. So now I'm on my next step where I need to do moles of oxygen to moles of H2O. So I'm trying to get rid of moles of oxygen, so that's going to go on bottom, and my H2O will have to go on top. So I'm using my orange conversion factor, so I have 1 mole of oxygen for every 2 moles of H2O. So again, units are canceling. Moles of oxygen cancels with moles of oxygen. So now I'm ready for my last step, where I just need to go from moles of H2O into grams of H2O. So I'm doing this last step. So this would have my green conversion factor, the molar mass of H2O, and I have moles on top right now, and I'm trying to convert it into grams of water. So my grams of water is going to go on top, and my moles of water is going to go on bottom. It is getting a little squishy, but hopefully you can read that. And then I multiply by all of my numerators, divide by my denominator, and this is like over 1. So plug that into your calculator and see what you get. And hopefully you get 38. And notice we have 3 significant figures, 1, 2, 3. So 38.5 grams of H2O, of water, will form if 34.2 grams of oxygen react.